So far, we've been talking about ionic compounds, and now we're going to move to a different type of compound called molecular compounds. Before we do so, one last review of what ionic means. So, an ionic compound is made when a metal combines with a nonmetal by the transfer of electrons. So, what does that mean? When I have my periodic table, we know that the metals have just a couple too many electrons. Like this first column or family has one too many, this one has two too many, this one has three too many. They want to give those up. And where do they go? Well, they go to the nonmetals. In this column here with fluorine, chloramine, bromine, iodine, all they need is one more electron, they would have a filled outer shell. This one needs two electrons to have a filled outer shell. So in ionic compounds, it's a transfer electrons, okay? So it's when we have a metal and a nonmetal, and the metals are giving up electrons and the nonmetals are gaining electrons. And over here I have a picture of exactly what's happening. So ionic compounds, they don't exist as individual particles. Instead, millions of ions are tightly held together in a crystal. Okay, so ionic compounds, metal, nonmetal, it's a transfer of electrons. One's giving them up, the other one's gaining them. In a molecular compound, it's a little different. We could call it molecular compound, or some people call it covalent compounds. So molecular covalent means the same thing. Electrons are not transferred, so no one's giving up electrons, no one's gaining electrons. What they're doing is instead they share electrons. And what results is something called a covalent bond. So covalent bond is when these ions are actually sharing the electrons. And what we see here, okay, is that they make up these individual molecules. Okay, so it's not millions and millions of ions coming together. We have these very individual molecules being formed instead. And here's a couple examples of molecular compounds. Oxygen gas, which is O2, so it's possible to bond with itself. Methane gas, CH4. Water, H2O. And we have to start getting familiar with some basic names. So when you see O2, you should click in your head, oh, that's oxygen gas. Okay, CH4, methane gas, that's another important one to know. Water, H2O, another important one to know. Writing the formulas for molecular compounds. It says always write the element furthest to the left first and write the ionic charge above it. So before, when we had ionic compounds, you always wrote the metal first, but the metals are on the left side, and the nonmetals second. Now with molecular compounds, they're both nonmetals, but we still keep with that because when you read, you always start on the left side of the page and you move to the right. So chemistry is no different. So you start with the one that's further to the left. So when I look here, carbon is more to the left than sulfur. So I'm going to start with the carbon. So whichever one is closer to the left is the one that you write down first. And then we put the charge above it. So carbon, well, I know this is 1 minus, 2 minus, 3 minus, and then the fourth column's 4 minus. So the charge above carbon is actually 4. Sulfur is a 2. Now, there's no need to put plus or minus because they're both the same charge. They're both going to be negative. So we just put the numbers up top. We do what we did before. The 4 comes down here. The 2 comes down here. So it's that crisscross the numbers using them as subscripts. So now there's a subscript 4. There's a subscript 2. So the formula is C2S4. And we can reduce this down. You could take a common factor 2 out of both of them. 2 goes into 2 once. 2 goes into 4 twice. So it says divide by the lowest common factor, CS2. So when you write the formulas, it's basically the exact same steps we did before. Naming molecular compounds. Now, when we wrote the formulas, the steps are almost exactly the same. However, naming is not. Naming is totally different. So what we do is we use these prefixes. And they should seem familiar to you. So mono means 1. Di means 2. Tri, like tricycle, tripod. A tripod has 3 legs, for instance. Okay? Tri means 3. Tetra is the prefix for 4. Penta, like in a pentagon, has 5 sides. Hexagon, if you think of that, the word hexa means 6. Hepta is 7. Octagon, we've heard the word octa, means 8. Nana is 9. And deca, like a decade, okay, is 10. Now, basically, we look at the formula, and however many of those atoms we have, we put this little prefix down. There is one exception. If the first one is a 1, we don't put the mono down, okay? And that's only if it's the first one. So let's do some examples. So if I look at this very first one here, there's 1 carbon. So when it's 1, I don't write down mono if it's the first one. So C is the first one, O is the second one. However, everything after the C, okay, will need one of these prefixes, even if it's a 1. So this is actually carbon monoxide, which is a very poisonous gas. So carbon monoxide. I know you might want to go monocarbon monoxide, but when it's 1, we don't put 1 in front of the very first one. So this one, C, there's only 1 there, so it's going to be carbon. Now there's 2 S's, so it's disulfide. The next one is S, so it's going to be sulfur. And then here it's trioxide. So sulfur trioxide. So the element in front, you don't change it. We don't put the I down there. So it's not carbide, monoxide. Okay, the one in front stays unchanged. The one behind, okay, the ending changes to I, just like it did before. All right, so the next one is C, so it's going to be carbon tetrafluoride. So the 4 there is tetra. Next one, okay, phosphorus, that stays the same because there's only 1. And then we have 5 of these bromides. So 5 is penta. So it's going to be phosphorus pentabromide. And then I have an interesting example at the bottom here. So this time, we don't have 1 in front. Okay, there's actually 2 nitrogens. So we have to use the prefix for 2, which is dinitrogen. And then there's 3 oxygens, trioxide. So the only time you use these prefixes is when we have molecular compounds. How do we know they're molecular compounds? That's when they're all the nonmetals. Okay, so when they're all the nonmetals, we know it's a molecular compound, and we have to use all these little prefixes. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Now we have a special kind of molecule called a diatomic molecule. Now, di, we just saw, means 2. So it's these molecules that actually bond with themselves. So 2 hydrogens, they can share an electron with each other and have a filled outer shell. And you need 2, and it becomes neutral. And I made this 7 thing up because what I noticed is there's 7 of them, and they make a 7 on the periodic table. So we have hydrogen over here, right? And then these 6 here that make a 7. And when I look at my periodic table, the diatomic molecules are nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay? So the way I remember it, and it's just me, you won't see this in the textbook, okay, is even with the hydrogen over here, they make a 7. So if you're writing out a chemical formula and I say oxygen gas, you don't just write down O. What you have to do is write down O2. So molecular compounds can actually bond, their elements can actually bond with themselves. And these ones tend to bond with themselves because if there's no one else around, oxygen is just going to bond with another oxygen beside it. Nitrogen is going to bond with another nitrogen beside it. So they're called diatomic because there's 2 of them, like 2 hydrogens, 2 nitrogens, 2 oxygens, 2 fluorines. And this is going to become really important in the next chapter because we're going to be writing out formulas, and I'll say chlorine gas, and you have to realize, oh, chlorine gas, I have to write down Cl2 because it's one of these diatomics. So whenever you see these elements, you never write them as just one by themselves, like you would copper. Copper, you just write down Cu. But these, if there's no other element bonding with it, it will bond with itself, and it's always a 2. For instance, oxygen gas is always O2. I want you to do this worksheet. So try it, look at the answers, see if you got it right or wrong. It's really, really important that you try it. So we're dealing with the molecular compounds. That's when the nonmetals are sharing electrons with other nonmetals. And I've written at the top all the little prefixes for you to see. So we have your mono, your di, tri, tetra, penta, hexa, hepta, octa, nano, deca. And what's cool is molecular compounds are even easier to name than the ionic because you don't need the periodic table. You just look at what it says and you can write it out. So for instance, carbon, well, there's nothing in front, so I'm going to assume it's 1, so you just write down a C. Monoxide, well, mon is 1, so it'd be just CO. Carbon dioxide, well, carbon, that's 1C. Di means 2, so it'll be O2, CO2. So you just have to read what this says and you write it down. For instance, this one says hexaboron. So hexa is 6, so I write down B6, and then mono is 1, silicide, okay, Si. So you just read what it is and write it down. Really, really, really simple. When you name it, it's the exact same thing. So this one is NO2. So we're going to write down nitrogen, and then there's 2 oxygens. So I look up here, 2 is di, so it'll be dioxide. So remember, what's in front, the ending never changes. It's just the way the element's written. However, the ending on the second element, the ion, okay, the ending always changes to "ide." So that'd be oxide, chloride, iodide. Okay, so the first one, whatever comes in front, the ending just stays the way it is. But the second one, the ending always changes to "ide."